I'm Dr.P.Usha Rani, Professor EEE Department of College. I'm going to explain about the reserve capacity calculation of the load curve problems. The data are the problem as given problem: a generating station of 1 megawatt supply a region just the following demands. They are given midnight from 5 a.m. and the load values they are given. And the data are midnight to 5 a.m. load is 100 and 5 to 6 p.m. no load, 6 p.m. to 7 p.m. 800, 7 p.m. to 9 p.m. 900, 9 p.m. to midnight 400. Neglecting the transmission losses, find the following. Plot the daily load curve and load duration curve. Find the load factor, reserve capacity and plant capacity factor. So first I'm taken the data of the time and load which is given in kilowatt. So starting from per day 24 hours, so they are given the load due for a particular time periods. So 100 megawatt for 0 to 5 a.m. and 5 to 6 p.m. or 18. Okay, so that time the load is no load. Okay, no load is used here, and 6 p.m. to 7 p.m. 800 kilowatt, and then 19 to 21, that is your 12 plus 7, so 7 p.m. to uh, the 21 means 9 is 7 to 9, 900 megawatt, then 9 to 12 p.m. that is 400 megawatt. So I have to frame this table. With the help of this table I can draw my load curve. Okay, x-axis load in kilowatt, y-axis load in kilowatt, and x-axis time period in hour. Okay, so 24 hours I have divided. So for the first duration 0 to 5, my load is 100. Okay, I have drawn, and 5 to 18. So from 5 to 18 hour there is no load here, 0. Okay, this value is 0. Then 18 to 19, 800 megawatts. So I have taken from 18 to 19, 900 megawatts load. Okay, 900 megawatts. Okay. Then 19 to 21, I have taken 900 megawatts. So this is my 900 megawatts. Then 21 to 24, the value of load is 400. So it drops to here 400 megawatt. Okay, 400 megawatt. So that is the load curve. Load duration curve was drawn from the ascending order of the values. Okay, ascending order of values, which is from 900 to 0 megawatt load. With the duration you have to calculate from the table what you have prepared. From that you have taken in the higher order of the load to the lower order of the load. If you draw with a particular time period, that is named as load duration curve. From the load curve we can find the average load. Okay, from the average load you can calculate load factor. The formula for load factor is average load by maximum demand. So here the average load formula is units generated per day divided by number of hours. Okay, that is the formula of average load divided by the maximum demand. By seeing the load curve, the maximum demand value is 900 kilowatt. So I have multiplied 900 into 2 plus 800 into 1 and 400 into 3 plus 100 into 5 divided by number of hours is 24. The maximum demand value is denominator 900. If I put that, my answer for load factor is 0.199, or in percentage I can say 19.91 percentage. And reserve capacity as plant capacity minus maximum demand. Plant capacity given as 1 megawatt hour. I can take it in kilowatts, 1000 kilowatt, minus maximum demand from the data is 900 kilowatt. So my reserve capacity is 100 kilowatt. That is the answer. And I am going to calculate plant capacity factor. Plant capacity factor formula is average demand by plant capacity, which is average demand. Already we have calculated for load factor, so which is 179.16 kilowatt divided by plant capacity. They are given as 1 megawatt, which I convert into kilowatt thousand. So my plant capacity factor is 17.91% or 0.1791. Similarly, plant use factor. The formula is units generated in kilowatt hour divided by plant capacity. In the denominator, multiplication of plant capacity into number of operating hours. This is not total hour which we are using for the plant capacity factor. Okay. Here we are using 24 for the average demand calculation. That's the major difference between plant capacity factor as well as plant use factor. How much hours we are operating. Okay, the number of operating hours only, not 24. It may vary. Okay, for this given data only 11 hours is used. Okay, remaining 13 hours is no load condition. So that's the difference between plant use factor and plant capacity factor. So if I substitute the values of units generated 4300 divided by plant capacity 1000 into number of operating hours 11. So my answer is 0.39 or 39.1%. Thank you.